So in this problem, we've been given the, the curve y equals 3 sine x. So that's a curve. And we want some area below y equals 3. So the upper bound line is 3. And it's going to be bounded between those two lines and the starting point k. Now, the starting point k is different for part 1 and part 2. So for part 1, we want to find the area in this region when k is equal to pi over 3. Okay, so this is for A, we're going to let k equal to pi over 3. And then we're going to find that shaded area. So to do that, we want to find the height of that area for each section. And then we're going to multiply that by dx and then add it all up. So the height of that section I've written here is the top line is 3 and the bottom line is 3 minus 3 sine x. So we're going to subtract those to get the distance. Okay, and then when we get that, we're, in this case here, let's just write it in here. So this is going to be 3 minus 3 sine x. Okay, so that's the height between those two, between the lines. I'm going to take that and give it some thickness, dx. And then I'm going to integrate that, sum all those rectangular slices up, starting at pi over 3. And then I have to determine the end point here. So we have to figure out where this ends. Okay, so this equation, sine 3x hits y equals 3 at pi over 2. So we can solve that, but we know that that's going to be the max of that sine function. And so that position should be pi over 2. So I'm going to integrate all the way to pi over 2. So there's my integral. So now all I have to do is anti-differentiate this. So this works out to be 3x minus, so the integral is sine, so we're going to, is net minus sine, so it's going to be positive 3 cos x. Okay, so the antiderivative of 3 is 3x, the antiderivative of sine is negative cos, so I end up with positive 3 cos x. And then my bounds are going to be between pi over 3 and pi over 2. So once I've got that, I'm going to plug in to my integral, so I end up with 3, write this out a little bit more neatly, 3 pi over 2, plugging in cosine of pi over 2 is 0, so I end up with that, minus plugging in pi over 3, I get 3 pi over 3, so that just works out to be pi. Plugging in 1/3 into the cosine function, cosine of 1/3 pi, so that's cosine of 60 degrees, is going to be 1/2, so I end up with 3 times 1/2 is minus 3 over 2. So then this works out to be 3 pi over 2 minus pi, that's going to be pi over 2, minus 3 over 2 is going to be plus 3 over 2, and this is an area, so we're going to be units squared. The second part of this is asking for volume. Now this volume that we're going to generate is going to be when we rotate this around the line y equals 3. Okay, so we're going to get some shape. It's going to be hard to draw this, but the shape we're going to end up with is this shape here. And that shape is going to be rotated, and so we're going to end up with some kind of cone on its side there. It kind of looks like, if you look from the side, it looks kind of like a mountain. So the volume is going to be generated again by the circular discs. So if I want to calculate the volume of this, I need to find the radius of that circular disc. The radius of that circular disc is going to be the distance between the line 3 and the line 3 sine x. So it's going to be 3 minus sine x. So that's going to be my radius. So I'm going to end up with pi. My radius is going to be 3 minus 3 sine x. And that's going to be squared. I'm going to take that and square that radius. So there's my pi r squared. I'm going to give it a thickness of dx. And then I'm going to integrate this from, in this case, the k value is different for this problem. So for part 2, k equals pi over 4. So I'm going to start at pi over 4. And I'm going to still end my integration at pi over 2. Okay, so there's my integral. I'm going to then, I should really just move this over a little bit so that doesn't look like it's too crowded here. Okay, so I'm just going to move that down. There we go. And so there's my integral, and that integral will calculate the volume when I rotate that region around that line. Okay, now it only asks you to write the integral because we can't actually solve this because we're going to end up with a sine squared integral, which we can't anti-differentiate.